Hello everyone, welcome to Energy and Power, a superconductor and perfect conductor for an electrical circuit. Now in previous video, I had done the Joule's heating effect, which is heat is equals to I square RT. And here heat, this is heat energy, so we can write this as energy. And here the power, since power is just equals to energy by time, we have I square RT by time. Therefore, P is equals to I square R. Now, of course, we have V equals to IR. So this is also equals to two other expressions in terms for resistance and voltage and in current and voltage. So here, this is equals to IV as well, and this is equals to V square by R as well. And here, these are all values of an expressions for power. Now we're on to superconductor and perfect conductor. Now, superconductors. Superconductors, they are the materials that have zero resistance and zero resistivity. That means the current, there is no opposing force to the current flowing. That means the current flows really fast. And here the superconductors, they obtain zero resistance and resistivity below certain temperature, and that temperature is known as the critical temperature. And these occur at actually very low temperature, most between less than 10 Kelvin, some 4 Kelvin, etc. They are obtained at very low temperature, and they have zero resistance and zero resistivity. What this in And also superconductors, they don't produce any heat, nor sound, nor light. Well, it can be explained due to the current resistance theory, which says the resistance is an opposing force to the current, and if the current has to flow past it, some work must be done. But in superconductors, there is zero resistance. That means there is no opposing force to the current. That means no work has to be done to the current to make it flow, right? And since there is no work done, that means there is no heat produced, and sound and light is also not produced. And here superconductors, due to their very high moving current, they are able to become diamagnetic materials. Diamagnetic materials are those which actually repel the magnetic lines of forces, which do not are not really affected by magnetic field, magnetic lines, and just magnet in general. Those are known as diamagnetic materials, which oppose the magnetic field. That means they are repelled from the magnetic fields, and superconductors become diamagnetic materials. They are perfectly diamagnetic materials, meaning no lines pass through it. And here they also follow Meissner's effect or Meissner's effect. So a Meissner effect is when a material goes below its critical temperature, and it goes into its superconductive state, superconductor, right? And as the material goes into the superconductor state, it starts to repel the magnetic lines towards it. That means it becomes more diamagnetic. And here, if you have seen some videos of Meissner effect, what happens if is that there is a magnetic field like this, and then the superconductor is placed right here, and when it goes below its critical temperature, it starts to go into a superconducting state, and the magnetic field like this, it actually repels it. So the magnetic field, it repels it, so that means it actually starts to float in the air, because it cannot come down, because its repelling force is making it go up and stay away from the magnetic lines. And that is actually very cool. I would recommend you guys to check out the Meissner effect videos, and because it's really interesting. But after this video, because I have to talk about perfect conductors. Now, well, superconductors, they are only work for certain temperatures. Sorry, certain materials. The noble metals such as gold, silver, copper, they cannot be turned into, well, superconductors because, well, they have to be below 0 Kelvin in order to become superconductors. And 0 Kelvin, well, they cannot exist as it is theoretically impossible. So we have perfect conductors. They are, well, basically the materials having zero resistance and zero resistivity, but they can occur at any temperature, while this has to be below its critical temperature. So this is purely a theoretical concept, this being experimental. And here, this cannot be a diamagnetic material because it is, well, theoretical and cannot possess diamagnetic properties, and thus they can't also follow Meissner effect. However, unlike superconductors, here in the theoretical concept that noble metals can in fact turn into superconductors or materials having zero resistance and resistivity. And, well, this is all for energy and power, and also superconductor and perfect conductor as well. If you learn something new, please like and subscribe. Thank you.